Hello everyone! In this lecture, I will introduce you with stack abstract data type and its implementation in data structures. During the lecture, we will look at definition of stack abstract data type, representation of stack ADT, operations of stack ADT, implementation of stack in arrays, implementation of stack in linked lists, and some example applications. A stack is an abstract data type commonly used in most programming languages. It is named stack as it behaves like a real-world stack such as deck of cards or pile of plates. Stack allows operations to be performed at one end only. This means adding and removing an element is only possible at top. Just like we can place or remove a card from the top of the deck. This feature is often called LIFO, stands for last in, first out. In this following slide, we can illustrate how stacks do operate. Let's assume we are pushing data by calling push method 4 times with some certain data. After adding last element on stack, let's go on and call pop method to delete the data from the stack. As you can see, element that was on top will be the one that is popped, or in other terms, be deleted. As we illustrate pop method 3 more times, we can see how top data is deleted each time pop is called. Stack has 2 primary operations as push with some certain data for pushing or storing an element on the stack, pop, popping or removing a previously pushed element from the stack, resize to resize fully filled array of stack, peek for getting the top element of the stack without removing it, is full for checking if stack is full, is empty for checking if stack is empty. Initialization of stack array using Java can be achieved with the following implementation. We declare size variable to keep track of the size of our stack array. Keeping track of size is not crucial, but a good way to understand how likely we are far from our array to be full. In the stack constructor, we create stack array with initial size to store elements. Let's assume we set it to 4. In coming slides, I will provide examples relying on this length for our stack array. And finally, top variable to store index value of the top element in stack array. Implementation of push operation can be performed by doing the following. Let's assume we call push method with newly created data. We check if our stack array is full. In this case, our stack is empty, so we skip if statement and do the following. We increment the top variable by 1, which will be now referring to first index of stack array, and add the newly created data to that index of stack array. Let's repeat the method 2 more times to familiarize ourselves with the flow of the push operation. Again, we increment the top variable by 1, which will be now referring to second index of stack array, and add the newly created data to that index of stack array. Increase the size, and so on. In this following slide, we will have a look at how pop method is implemented in stack array. We know that we can only pop if we have data in the array. So, if our stack array is not empty, we do the following. We create a local variable of removed data to know and return what data we have deleted in our stack. We know that the data which will be deleted will be equal to the data of what peek method returns. As you remember, peek method returns the top data in the stack. Then we decrement the top as it should refer to now index 1 of our stack array, and also decrement the size as now we only have 2 elements in the stack, and return the removed data. Here you should pay attention that we are not deleting an element in the memory, but in fact only directing our top index to see the previous index in stack array. Therefore, I grayed out the stack array index instead of erasing the element from the stack. Later on, when we will push new elements on the stack, they will be overwritten on the ones that were occupying place in the memory space. If this is cleared out, let's go on and call pop method once again to familiarize with its logical flow in stacks. The next method we will look at is peek. Peek method simply returns top index of stack array if index is not empty. In our case, it will return data that is stored in index of 0 in our stack array. Another useful method in stack array is resize. To illustrate how resize method works in Java, let's go on and do some push actions in our stack to fill our stack array. Let's assume that we are calling push method 3 times. If we would call push method 4th time, it would trigger the resize method since our stack array is now full. Now, we can see how resize would behave to resize our existing array when it's triggered. First, we create a local int variable of new size, which will indicate the new size of our new array. In common, we increase the size of new array by double of the size of existing stack array. Then, we create a new local array with same type as our existing array and define its size as the size of the new size variable. In our case, temp array will be with size of 8. Pay attention that this new size is not the same as the size variable we have declared at the initialization section of stack array. Next, we should now copy elements from existing array to the newly created array. We can achieve this by simply going through the stack array and taking every element by index and copying it to the temp array's same index. You can see how iteration is illustrated with every action. When I variable will no longer be smaller than stack array's length, we will now say that our newly created array will be our updated stack array. As local variables are one-time storage actions in memory, we will no longer have dump data in the memory as temp array will no longer be existing in the memory. In this slide, we will see how isEmpty and isFull Boolean methods are implemented in stack arrays. These two simple methods just checks if our stack is empty or it is full. By knowing this, we can control the flow of the other methods depending on the Boolean return. So let's go on and have a look at how these two methods are implemented. IsEmpty returns null if it sees that top is equal to -1. In isFull Boolean method, you now can understand one advantage of keeping track of size. This will simplify the detection on if our stack is full or not. In linked list implementation of stacks, there are almost same amount of operations but with some differences. We have same operations for same purposes as push with some certain data, pop, peek, isFull optional, isEmpty optional. One of the major differences from the stack array is that we actually don't need to have a resize method in linked lists, because we know from previous slides that linked lists can expand and contract as needed. As you can see, isFull is optional. This is a good reminder why we call abstract data type abbreviation due to the independency on the way how data structures are implemented. isFull can be implemented optionally if we want to limit our linked list expansion not to fill linked list more than the required amount of data. IsEmpty is also optional. It is because we can see if our list is empty by simply checking if our node is null. We will see in the following slides why these two operations are indicated as optional methods and understand it why they are optional. First, at initialization part of stacks for linked lists, we need to have node class as we are dealing with the linked list structure. As we know, data elements in linked lists are stored in nodes. That's why we need node structure to store our data in a linked list formation. In initialization part of linked list stack, we should have top node, which will always point the lastly added element on stack. We declare variable size to keep amount of data stored in our linked list stack. Push method in linked list stack implementation is performed as follows. Let's assume that we call push method with some certain data. We need to create new node with data that is not pointing to any other node at this moment. Next, we point this node to the top of node and change the top to be newly created node. This will ensure that newly added node is now our top node. We increase the size by 1 as we now have one element in our linked list stack. Let's repeat this operation once again to familiarize ourselves with the flow of the push operation in linked list stack. In pop operation of linked list stack, we first check if our list is empty. We basically can check it by looking at the top node state. In our case, it's not, so we proceed to the body of our pop operation. At the second stage, we create a local variable of temp, which will be storing data to be deleted to know what data we deleted. We set it to the data that is stored in top node. And now, we basically point our top to the next node and decrement our size by 1. After decrement, we return the data which is deleted. Peek method basically returns the top node's data, and this way we know what is stored at the top of our linked list. There are numerous applications of stacks, such as compilers and parsers are expression evaluations done by stacks, by postfix or prefix using stack in compilers. This way, we can determine if users are using correct syntax in a specific programming language. Activation record is data that keeps track of the procedure activities during the runtime of a program. This gives good overview on what kind of actions a user took while using the program. We also use stacks to implement other data structures such as searches in graphs and trees, which are other complex data structures. Reverse Polish notation gives opportunity in preprocessing for computers and mathematical calculations. This way, computer doesn't need to check where the specific parameters are expressed by user input, but instead uses postfix method with stack implementation to give the right answer. We have said that most of the parsing uses stack to check user inputs for correct syntax. In this example, we will look at an XHTML script and see how stacks are involved in parsing. The strategy for parsing an XHTML syntax is we read through the XHTML linearly and place the opening tags in a stack. When we encounter a closing tag, we check if it matches what is on top of the stack and take the required action. So now, let's see how stacks will be used for checking XHTML syntax. I colored opening tags and closing tags with different colors for better understanding. This has nothing to do with the method used to detect opening and closing tags in a particular method. Let's assume that we have logic where we check if XHTML opening tag is detected and add it on stack whenever it does. We know that pop tag should be equal to the tag on the top of the stack. This way, we know if the syntax order is correct, because if it doesn't refer to top, we can just throw error for user that syntax at top of the stack is missing. In this example though, we only look how stacks are using the methodology in parsing of XHTML language, so we don't need to throw any kind of error. Thank you for your attention. See you in the next lecture.